Hi everybody, it's still me, Miss Leia, and in this last video for this playlist, we're still gonna talk about freely falling bodies, but this time we'll be dealing with problem solving for case 3 of freely falling bodies, which is all about objects that are thrown upward and are influenced by gravitational pull alone. Alright, so that's case 3, and we have a few things to remember for this particular case. First is that for objects thrown vertically upward, the magnitude of initial velocity is, of course, greater than zero because you cannot propel something upward if you don't give it an initial momentum that it can carry throughout its motion. And then the sign, of course, is positive because it's thrown upward and upward direction takes a positive sign. Now there's this video clip from the movie Avengers Endgame. I'm not really a fan of this, but just for some reasons, there was a time when it popped out of my YouTube recommendations, and it seemed interesting, so I just clicked it, just a random click, and I saw this particular scene. Okay, not sure if that was fine enough, but yeah. So what happened was Captain America used his shield to propel Black Widow upward, and just to allow you to feel it even further. Just like this. So there you have it. So that's free fall case 3, right? And I made a question out of it. Object thrown upward, free fall case 3. This is what I came up with. Suppose Black Widow reached her maximum height in a span of 0.88 seconds. What velocity did Captain America impart on Black Widow in such case? Assume that acceleration is equal to negative 9.8 meters per second squared. As far as I know, it happened in a different setting. It's not really on the Earth, but because of the motion of the people in this particular clip or in the movie overall, we can assume that acceleration is the same as that here on Earth because of course it's if it's not something close to this, they would move very differently, right? Okay. Yeah, so we have to solve for this one using the same problem solving steps that we have learned earlier in the previous parts. Okay. Now suppose Black Widow reach her maximum height in a span of 0.88 seconds. What it wants us to figure out is the velocity that Captain America imparted on Black Widow in that particular scene. So to visualize that better, you can make a sketch, something like this. This could be Captain America holding his shield, and then she propels, okay, Black Widow upward. So she reaches a certain maximum height, right? Given the strength that Captain America gave. Okay. Now, what do we know about the problem? That's the first step. Okay, so given we have the time as 0.88 seconds, right? The question is, what velocity did Captain America impart for Black Widow to get to that maximum height, which happened in a span of 0.88 seconds. Okay, now we also know that acceleration is negative 9.8 meters per second squared. Okay, and then one more thing you have to remember. I actually forgot to mention it earlier in the recap, the one with the table. But final velocity for case 3, free fall, is 0 meters per second because for an object thrown upward, they actually stop momentarily at their maximum height and then they will fall back down again due to Earth's gravitational pull. What else do we know? We know that the RTF is, can you guess? No, don't guess. You have to think. Okay, so the required to find is initial velocity, right? Because we're being asked what velocity did Captain America impart on Black Widow in such case. So we know that this velocity right there is zero. So that's the final. It's the one that happened at a later time. Okay. And then this one would be the initial velocity, right? The starting velocity of Black Widow right after he was propelled by Captain America with that shield. Okay, so those are all the given, and this is the RTF. Of course, the missing variable would obviously be displacement because once again, missing variable is the variable that's not a given, but it's also not the RTF. There we have it. Okay, now why do we need to know the missing variable again? It's simply because we have to pick the equation that does not contain the missing variable, and that's no other than equation 1. It doesn't have displacement. So we're going to use equation 1 and solve for that. So equation 1 is v sub f equals v sub I plus 80. Okay, and because we're solving for v sub I, we need to isolate this one, right? Okay, now once again, like what we have often done in the previous problems, if something is 0 in the problem, we have to cancel that. Let's say, for example, v sub f is 0. We can cancel it in the equation for simplicity, okay? And then v sub I is the RTF, so we want to retain it to be positive. So instead, we're gonna transpose 80 on the left side of the equation. So it becomes negative 80 equals v sub I. That's it. It's the final equation already. You can flip that horizontal. It's okay. So it's v sub I equals acceleration times time. Okay, let's plug in the given values. Okay, so acceleration is negative 9.8 meters per second squared, and then time is 0.88 seconds. Okay, I hope that's right. 0.88. Yeah, it's 0.88 seconds. Okay, so all you need to do is to, okay, I forgot the negative sign. We transpose it, so it should be negative. Okay, so there's another negative sign right there. Okay, in case you got lost, let me recall it a bit. Okay, so the equation is this one, and then we transpose 80 to the left, so it becomes negative, right? Okay, and then if you flip the equation horizontally, so that's the RTFS on the left, it will become like this. So v sub I equals negative 80. Okay, now that negative is this one, right? So it's the negative outside the parentheses. And then acceleration is also has its own negative sign as well. So negative 9.8 meters per second squared times time, which is 0.88 seconds. Okay, now if you do the math, okay, you're supposed to get, okay, take note, negative times negative is positive times positive. So the final answer here should be positive. Okay, the final answer is 8.62. Okay, so 8.62 meters per second. That's velocity, right? You're gonna cancel this. And then one more s because this is raised to the second power. So the unit is meters per second. Okay, now let's look at this. Yeah, so it's 8.62 meters per second. Why is it positive? Because it's an upward velocity, right? Okay, so that's actually pretty low because you can actually, if you rewatch the particular clip, it looked effortless for Captain America. He only, it's like he only designed or plotted out his push or propel such that Black Widow gets to reach the Chitauri army space. So okay, going forward, yeah, it's basic for Captain America. That's pretty low. It's an average value now. Okay, so that's how it works. That's actually there. I have a good takeaway from that problem. We can be an instrument towards other people's progress in certain endeavors, right? Like Black Widow would have not made it without the help of Captain America. So whether it's a big or small sacrifice or a little or great effort, we always get a sense of contentment or sense of purpose when we get to do some small contribution to other people's endeavors. So yeah, life becomes more meaningful when we're here for each other. Okay. At this point, I'd like you to answer the quiz items in part 4 of the learning playlist. And after you complete that task, submit the form or continue with the other tasks. Actually, you only have part 5 after this, which is the reflection and self-assessment. Or submit the form and take a break. Okay. So if you're not satisfied, because that's actually a pretty easy example, there are 2 more examples that comes in PDF format in the same playlist part 4 still, okay? So they're also uploaded there as optional tasks or alternative tasks.